Good morning, everybody. Good morning. How's it going? My name is Ben Hagan. I'm here today to talk to you a little bit about something that I have chosen to call reactive cloud security. And this is going to be a little interesting. This is the first time I've given this talk, not to set myself up for failure, but it's something I'm kind of excited about, and I think it's more of a call to action for those of us who work in really interesting cloud environments, kind of DevOps infrastructure, working in security in kind of like modern day environments, to kind of change the way we think about how to respond to threats and how to kind of work with the environment to actually make your security better. And I'm a very, very strong believer that just because your application is in the cloud doesn't mean that you have second-rate security or your options are limited. I actually think given the right mindset and the right tools, that hosting your application in the cloud sets you up to have even better security than being in a traditional data center or something like that. I'm going to have to keep my laptop in this in sync, so if I miss one or the other, just let me know. So basically, I'd like to talk to you a little bit about myself, of course. I'm going to introduce myself. I work at Netflix. I'd like to give you a little introduction to how Netflix runs things, and then kind of dive into this notion of reactive cloud security. And hopefully, I'd love to have kind of a conversation around what your thoughts are on it. So to get started, let me talk about myself. And the only reason I do this is because I'm not trying to sell you anything. Hopefully, you're already customers of Netflix. If you're not, maybe you will after this because you're so impressed by our awesome security. But unlike a lot of people that are at conferences, you don't need to buy products from me. I'm not trying to sell you a solution. I really just want to make things better. So hopefully we can do that together. So I started off actually with a very technology-relevant degree in political science. Really set me up for success. I think I quickly realized that I was not destined to be a lawyer or diplomat and switched over to information assurance. And this was all at Iowa State University. Anybody from Iowa here? This guy's awesome down in the front. So it's a great program. I highly recommend you look into it. It's one of the NSA kind of affiliated schools. A great degree in kind of computer security there. I started off my career at a wonderful company called Motorola. You may have heard of it. I started when they came out with the Razr phone, and I left 5 years later when they were just getting into that whole touchscreen Android thing, and then after that it just was a quick downfall. But really, I think Motorola was responsible for more Dilbert storylines than any other company in the world, and I think my experience there certainly validated that assumption. It was a great place to come up to speed on security because they had so many problems. But I learned a lot, and I think it kind of set me up for the rest of my career. I switched from a security operations center role looking at like millions of events a day into consulting, doing penetration testing, application assessments, architecture for kind of cellular providers all over the world, quickly moving on to another company called NeoHapsis, which is a boutique security consulting firm based out of Chicago. So again, doing like penetration testing, architecture, that kind of thing. And it came around to, I think, 2011 when I sat down to dinner with a good friend of mine who had just started as the CTO for the Obama re-election campaign. And we were having a conversation around what it's like to work on a campaign. What is he worried about on a day-to-day basis? Like, how are they going to do? I think people were confident that Obama would be re-elected, but nobody knew for sure. And he sat down with me and said, Ben, I can't sleep at night. I'm kind of worried about this whole anonymous, like, lulzsec was like right in the prime of their like causing trouble stage. And he was worried that because of security, that everything they were building could be brought down at any given time, and that all the work they were doing could be for nothing if they weren't paying attention to kind of security threats. And I said, that's something I might be able to help you with. Talk to me in a couple months. But then in a couple months, I actually did join on full time and spent about 1.5 years leading security for the re-election there, which is where I met some fine people like Leo down here in the front and a few others in the audience. The great thing about working at a campaign is actually you know exactly when you're going to have to find a new job. And it just so happens that it's about a week or two after election day. Go figure. And when it came time to kind of decide what I wanted to do next, I thought about my work on the campaign. It was really my first experience with working in a truly modern kind of cloud environment. You can see some fantastic presentations a bunch of us have given on how we used kind of AWS in that campaign environment. And I thought about security and how kind of security had not really stepped up to that new change in how we deployed applications. And I wanted to work somewhere where they were willing to invest the time and energy to actually get it right and to do something new and to look at the problem fresh and try and do kind of the right thing. And I ended up at a company called Netflix, which is where I am today. I lead the security operations and tools team. We are the ones that, one, we get to hold all the kind of God controls on our Amazon account. But ultimately, we're responsible for security within Amazon. And if you've seen any presentations Netflix has given on how they do cloud deployments or application development, you know that everything Netflix does is in Amazon, which catches a lot of people by surprise. But everything from kind of the application stack to the API calls to all of the recommendations we try and give you and you probably ignore, all of that is actually done in AWS. So we have one of the largest kind of deployments in the world, and we'll get into that here next. So talking about Netflix, hopefully, again, you're familiar with it. We have over 81 million members worldwide. I have to change this number every time I give the presentation. We support over 1,000 different devices. So these are things like toasters that might have a video screen on them, TVs, PlayStations, browsers, of course, mobile devices, that kind of thing. And we have this weird idea that we want your videos to work no matter how old your device is. So we have devices way back in the Stone Age, like 2008 or 2009, when streaming first got started. I believe we support all but one platform still. And I will not name that platform because then you'll all yell at me for not supporting it anymore. We are available in every country with an asterisk. The only two countries we're not available in is China and North Korea. And we hope to be available everywhere at some point. Maybe North Korea will never happen, but hopefully China at some point. We do concurrent delivery from 3 different global regions, the East Coast and West Coast of the United States, and then Europe. This is a full application stack. We do consistent and practiced failovers between regions so that if there's an issue on the East Coast or West Coast, we can transition all of that traffic somewhere else so that you can still watch your videos. This is another number I have to change all the time, but we are currently responsible for just over 1/3 of all US broadband internet traffic. So all of those bits and bytes going over the pipes leading into your houses and businesses, we take up about 1/3 of that during prime time hours. So we're to blame when the internet slows down. We have thousands of developers, actually not thousands, just over 1,000. And we have a fully microservice architecture such that we have thousands of application endpoints. And each of those is kind of deployed individually in a true kind of microservice strategy. We have an incredibly large monthly Amazon bill. And we've been with Amazon so long that the urban legend is that when we first got started and really scaled up, Amazon was still mailing out paper billing. And every month we would essentially get 1 or 2 phone books of itemized receipts from Amazon detailing our entire usage pattern. Thankfully, that's transitioned to a CSV file or other downloadable report. But I would challenge anybody here to compare billing size. And we design everything with elasticity in mind. So really the idea is as demand grows, the presence within Amazon grows. We can add more machines. We can take them away. And really we try and be as environmentally friendly as possible with our EC2 usage, but try and utilize it as flexibly as possible. We do this crazy thing called trusting our developers. And one thing we trust them with is doing their own DevOps. So famously, Netflix says we do not have a DevOps team. That's kind of true, kind of not true. We have a team that develops tools, but ultimately each application owner builds their own pipeline and pushes their own buttons to actually deploy their application into the cloud. So in terms of understanding what you need to do and actually managing that pipeline, every developer does that for themselves. They have a team they can go to with questions. They have a team they can go to with things like feature requests, but ultimately the application owner does almost all of their own work. We utilize something called the immutable server pattern, or an immutable server pattern. Basically, we function off of pre-baked AMIs. So whenever you change your application, you make a new snapshot of it, save it as a disk image within Amazon, and then when you deploy it, you're deploying a consistent image that you know is hopefully good. And when you scale, you're just adding more of that same image. You're not doing any configuration on the fly. If you need to do an update, you actually take a new snapshot and redeploy everything. And we call that the immutable server pattern. Like I said, everything scales to the point that if you have what we call a tier 1 service, so that you're directly in the line of fire for streaming videos on Netflix, we expect you to be deployed within 3 availability zones in each region, and then available in all 3 regions that we serve out of. So no matter how small your application, we expect you to have at least 9 instances running at any given time. You're deploying in an auto-scaling group every time, and you have an ELB in front of you to distribute load. So that's kind of the basic pattern that every application follows. And we do enough deployments every day. I think it's on the order of 300 to 400 deployments, that the average lifetime of an instance is just over 3 days. And again, this number changes all the time and varies greatly based upon how we scale and how we deploy things. But that world where you had a data center and you had a server that lived for like years on end obviously isn't here anymore. And we've had to figure out ways to kind of manage this new world where everything is ephemeral. And that's been a great motivator from a security point of view. And we certainly try and be innovative in our solutions for it. So security. Did my emoji work? No, it didn't work. Those are supposed to be hearts, by the way. So security at Netflix is kind of similar to DevOps in that we try and enable application owners to actually own their own security. We're a relatively small team managing security, and we cannot do everything. We do focus on automation, self-service development, and then providing kind of architectural guidance. But fundamentally, like we just don't have enough time or people available to kind of give the attention to applications that each one deserves. So we actually give the responsibility for security back to the application owners. And we act as a consulting team, essentially, where we want them to make the right choices. We want to enable them to make the right choices, and we want to give them the tools they need to have a secure base on which to build their application, such that they can own their own security, and we just help them make the right choices. And we call that a paved road, a paved security road, where if you're building an application using the normal stack of tools and the normal architecture, you're going to be pretty good. But if you need to go off of that road for some reason, that's when you should come to the security team. That's when you should come talk to us, and we'll help you make the right choices. And it will help you, develop the tools or features that you need to actually have a secure service. And this is taken to the extreme, where every developer on our team has root access to almost every instance within our environment. So as a developer, you can log into any instance you want to, with a few exceptions, of course. Things like PCI kind of restrict that, but generally, you have access to almost everything. So that's a fundamental difference, probably, from the kind of environments a lot of you guys are dealing with. But it's something we've been pretty successful with. We trust our developers. We trust them to make a lot of their own choices, but we're there for them if they have questions. That's security. So let's talk about this thing called reactive cloud security. And the first thing we should talk about is what the old model is. So how many people here are security people? And how many people are kind of doing the DevOps thing or want to do the DevOps thing? Great. So this may look familiar, right? In the old model, you have things like network firewalls, right? And if you observe something you don't like, if you observe an attack, you block the traffic. So you put a rule in the firewall and you say, don't allow this CIDR range from this geographic region to come into my system anymore. If you have an intrusion prevention system monitoring network traffic, you're probably setting it up to block on suspicious behavior, right? It notices that somebody might be trying to exploit some vulnerability in SSH. You block the traffic. Similarly, if you have a web application firewall and you see somebody hammering your website, you block that traffic. If you have authentication and authorization, which I hope you do, that's all there to block the wrong person from connecting and having the wrong privilege, right? So authentication itself is blocking people from connecting. what do you see in common here? Anybody see a pattern with this kind of methodology? You're just blocking, 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 blocking. And as a really smart, attractive security professional, I'm bored with this kind of thing. I think we can do better. I think we can have more interesting solutions. And that's where I really think this kind of reactive, modern environment can come in handy. We can do things that take advantage of the environment that we're operating in. So we have these really dynamic and flexible pipelines for applications to get deployed. We have environments that scale up and down. We have amazing APIs that give us access to kind of rich, detailed information on our environment. And if we're just blocking things, we're not taking advantage of that. But I think in a world where our applications are dynamic, our reactions from a security perspective should be dynamic as well. So what is reactive cloud security? It's security which understands the environment and takes advantage of it and modifies it to actually respond to threats in more ways than just by blocking things. So you need to architect your environment for change, which hopefully if you're doing kind of modern DevOps principles and modern deployment methodologies, you're doing. Your security model should understand and leverage those changes. Fundamentally, blocking things is not interesting. It does not realistically respond to a threat. If you have a cloud environment, your attacker probably has a cloud environment too. If you have dynamic ephemeral IP ranges, so does your attacker. If you're blocking one IP, that really means nothing in a modern world. So reactive cloud security should understand the context within your environment and then actually adapt your environment to respond to that threat and to respond to the different security conditions you might be observing. Sounds great, right? It's not that easy, of course, but what are some things you can do with a modern environment? So most of these are Amazon related, but the same is true with almost any cloud environment, right? So you see something happening, you could scale an auto-scaling group, right? You can give yourself more compute power. You can give yourself more processing to deal with an attack. You can modify a security group. Here you might be blocking things, but you might also be kind of limiting or throttling traffic. You can adjust the actual permissions with which you interact with Amazon. So you see an attack happening, you may want to kind of triage that and limit the scope which that application has access to within your environment. You can turn on or off logging. Logging is complicated, it's expensive. You can kind of dynamically turn that on when you see something happening and turn it off when you're not worried about it. You can isolate a system. So if you're afraid of something being compromised, you can move it into a special part of your network that actually doesn't have any access to anything. You could tag a system. So this is just building out your environment with kind of robust knowledge, right? So for example, if you have instances deployed and you see one of your own developers SSHing into it, you may want to flag that and say, this instance has been touched by somebody. It's not off of a standard pattern anymore. It has been, it's dirty, Somebody has logged into it, somebody has done something, and then you can take that information later and react to it. You could actually redeploy a system. You could rebuild your entire image based upon a vulnerability that you've identified and push out an entire new version of your application. Or you could shift all of your traffic to a region that may not be experiencing the problem that you're trying to deal with. So at Netflix, we have, like I said, 3 regions. When we have an environmental problem, we often, as a first response, will shift all traffic into an entirely different region and then deal with fixing the problematic region without users being affected by it. And I think the list goes on, right? If you're doing something in a deployment pipeline, you can probably impact security with it as well, and you can impact it for good. So again, those are really powerful tools, right? But how can you actually implement them? And I think it's a growing process. I think there's no necessary best practice at this point, but I think it's something we're going to see more of and evolve into a much more interesting format. But I think there's some very easy strategies we can follow. So the first thing is looking for binary conditions, right? There are some things you know that should never be different. Your environment, for example, there are things that never change or never should change, and if they do change, something wrong is happening. Easy examples of this, right? CloudTrail, your logging of access to Amazon resources, that should probably always be on. And if you ever notice it being off, you can respond to that. Administrators should probably have a lot of privilege, and non-administrators should probably not have a lot of privilege. And if you're able to audit that and see a change, and suddenly somebody who shouldn't have a lot of access has a lot of access, you can respond to that. External traffic should probably only be terminated on a load balancer. And if it's going somewhere else, or you notice traffic going directly to an instance, you can respond to that. And likewise, life cycles and that kind of thing can also be automated. Your SSL certificates should probably always be valid. So if you notice within your certificates, one has expired, you should probably redeploy it, or reissue it and then redeploy it. These are conditions that are always true or false. And if you notice them being different, you can kind of make changes automatically to correct it in almost every circumstance. So instead of binary, we can also have fuzzy conditions, right? Things that may indicate a problem. Things in your environment which could change, but you'd want to be aware of. You see a web server that has a CPU spike. Normally, maybe you never break 20%, but suddenly it's at 90%. Something weird might be going on, and you may want to respond to that. Patterns of inter-application traffic. So hopefully, you kind of document and understand what applications need and what they talk to. And if you see something out of the ordinary, that's a sign of a problem, right? If your messaging system is suddenly talking to your user accounts, maybe that's not an expected pattern. And you can actually respond to that dynamically. Hopefully, your engineers and administrators don't log into systems very regularly. But if you notice systematic logins to every instance in your account, that could be a sign of a problem, right? You may be looking at CloudTrail logs and you see a spike in APIs that are never really used. Again, that could be a problem, or it could be somebody doing their job. Traffic patterns, et cetera. The list kind of goes on, right? But the idea is you have a couple buckets here in which events can fall, and some of them are easier to react to than others. For the binary conditions, you definitely want to correct that. For these fuzzy conditions, you probably want to investigate it and look into it a bit deeper. So how do you do the detail work here? Like, how do you actually leverage this information? So Amazon has something called CloudTrail. Hopefully you're kind of using it. It is essentially a log of how people are accessing Amazon's APIs. When you launch an instance, or if you redeploy something, or modify a security group, or modify access privileges, all that's going to be reflected in CloudTrail. So it's a very important part of the puzzle here. You've got to make sure it's turned on. And you should turn it on for everything, for all the regions. People have documented interesting ways to kind of subvert the system by maybe hiding one of the regions and doing something nasty. You should just check and make sure it's turned on everywhere. You have kind of two options to actually leverage this. You can, by default, CloudTrail goes into S3 as a big JSON blob, or lots of little JSON blobs. You can also send it to CloudWatch logs, which is kind of like Amazon's built-in log management solution. It has kind of a high latency. It's about 10 minutes, 10 to 15. Or you can use a newer feature called CloudWatch events, which actually uses a push model. So when something happens, it'll send out an event notification to a service, and that ends up getting to you much quicker, so in about a minute. And I believe they're working on making all of this faster, of course, but it's not real time. Both of these can be connected to Lambda, which is an amazing kind of serverless architecture they have. And then you can write very simple functions to respond to events. So you see an event turning off CloudWatch, you can write a Lambda function that turns it back on. You see an event triggering off of machine usage, you can respond to that by maybe launching more instances and adding them to your ELB. Lambda is kind of the logic that's working off of all of this intelligence. So they identify, log, and notify, and then react to the different conditions. The important thing here is to have a little bit of an out for your administrators, right? If your privileged user is doing something, maybe that's a whitelist or blacklist kind of condition, so that you don't lock yourself out of your own account or something crazy like that. I've actually done that a couple times. It's not a fun thing. So that's kind of the Amazon side of it, but of course we have non-Amazon things as well to worry about. And with that, it's about having a robust infrastructure to log and kind of gather instrumentation from your environment. you need to be able to access it programmatically. That is the key here. So unless you can actually do automation off of log events, it's not going to be much good. And you should send everything you possibly can there, right? So access logs, authentication logs, performance logs, everything. And that pipeline is really difficult, right? A lot of companies will charge you a ton of money to set it up. You can do something pretty good, very cheaply, very simply. There's something called the ELK stack, which is, I always get this wrong, Elasticsearch. What's the L? Logstash and Kibana. Essentially, a poor man's log management solution. But you can do an awful lot of work with it. And Elasticsearch is, by definition, an API. You can interact with it very easily. There's lots of other options here. Of course, Amazon has CloudWatch logs. You can pipe your own events into there if you want to. Amazon has CloudWatch metrics. Companies like Datadog, Splunk, New Relic will charge you quite a lot of money to do this for you. But they're great tools, right, if you can actually get them working in your environment. At Netflix, we use something called Atlas. We've open sourced it. It is a big solution. It's very, very performant for metrics. I think we're logging 500 million events per second to Atlas right now. It's a major part of our environment and basically the brains behind almost everything. We do use Elasticsearch and a lot of other big data pipelines as well. But the goal here is basically to get your data and to be able to use it and to be able to react to it. And I think all of these tools are part of the puzzle again. It's up to you to decide how to actually implement them. So generically, talking about strategy, and I'll get into a few actual details in a second, we have something that I am calling the red silo cups of security. If you all went to college, hopefully these kind of cups are familiar to you. But I think there's generally 3 different buckets or cups of events that you need to look out for, right? Again, the things that you can fully automate, these are great. These are things you're comfortable writing a script to respond to. These are those kind of events where, the binary conditions, where you know for a fact that, you need to react to it. You have another bucket of events called things that are almost automatable. Maybe you want to have a little bit of oversight. You want to have an engineer or analyst take a look at it to actually do some investigation, and then maybe based on that investigation, push another button that makes a change. And then you have things in a third bucket that you can never automate for whatever reason. Maybe it's compliance, maybe it's a discomfort with the environment, maybe you don't have that automation in place to actually make this change automatically. These are things that you're never actually going to be able to leverage in this kind of pipeline. So I think generically, right, and I think it's pretty obvious, you want to minimize the things in bucket number 3, get them into bucket number 2, and then transition them into bucket number 1 as you're comfortable doing it. And if you have a lot of things in bucket number 3, there's probably something else going wrong, something systemic, something you need to look at and actually fundamentally change with your architecture so that you do feel comfortable automating things, so that you do have the right information to make your choices. So I think bucket number 2 is a baby step to actually having everything be fully automated. Ideally, your entire environment is tuned and instrumented to the degree where you can actually trust it to make its own decisions in most cases. Silo cups. So we've talked about a lot of stuff. I've mentioned the ELK stack, which is Elasticsearch, Logstash, and Kibana. I learned something today. Lots of buzzwords going on. Let's talk about a few more. So ChatOps, I think this is a new, so I'm from San Francisco and Silicon Valley. This is a new awesome thing that everybody is talking about, right? Everybody loves Slack, HipChat, those kind of things. Essentially, it's using your kind of communication stream to log information such that your people don't need to shift context from communication to actually making changes. So imagine you have these events coming in, they actually go into your chat channel, you can make action, you can take actions, you can do investigations, all of that actually from your chat environment. And that's what people are calling chat operations. It's kind of a baby step, right, to that fully automated perspective where you want to have humans as part of the process, but it's more or less automated at some point. The advantage of it is, again, that you share a single interface and it provides notification. You log what kind of work you're doing, you're providing context, and then it lets you interact with your tools as well. And the real win here is that you're not jumping between different windows, you're not loading different websites to do different things, everything is happening within one context. automation will get you that context, and hopefully automation will take care of whatever action you need to do, but fundamentally there are humans monitoring that channel, right? They approve and they execute commands. And I think the only caveat I have to this, I think it's a great, really powerful tool, is that two-factor authentication is super important here. You don't want to trust your chat channel to actually make really important changes without having that second factor implemented as well. I have an example. This is a chat bot. So Audit bot here is automation. Oh, thank you. There we go. Audit bot is a chat bot. This is in Slack. I wrote Otterbot because I love otters, and I wanted to not do my job as much as I was doing it, so I implemented a bunch of automation here. And let me walk you through what's actually happening. So at 4:08 p.m., nothing had to be done. But at 5:07, Otterbot noticed that somebody had pushed a change into a repository that actually updated a IAM profile template. So IAM is your access rights within Amazon. And then Otterbot synced that over to an S3 bucket where it stores a truthful state of what your profile should look like. It then ran a change detection script that said, you've pushed a change. It looks like that change needs to be applied to your environment. And because this is something really important, this is your actual core rights and profile within Amazon, we don't want that to be fully automated quite yet. We're kind of baby stepping our way to feel comfortable with it. So it's actually created an internal ticket within Otterbot to implement that change. There's my handsome face there. Noticing that there's a ticket and approving that change, Otterbot then sends out a two-factor verification using Duo. I got that verification on my phone, and I hit accept, and then it implemented the change for me. So this would have been something that would probably take 5 or 10 minutes. Not a lot of time to do manually, but within the context of this chat channel, you can kind of be made aware of the change and implement it within a matter of seconds. And that's really the win here. You don't need to leave the channel. Additionally, you could describe the change if you wanted to be made aware of what's going on. So that's kind of the concept of chat ops, right? Notification, investigation, and then response all within your chat channel. One more thing. And this is something we've been really big on at Netflix recently. We call it right-sizing your environment. The idea here is that security right is something you can monitor. Access to a system is something you can monitor. And you really want it to be the perfect fit for what you're trying to do. You don't want to give somebody too much access. You don't want to give them too little access. Either they'll be able to do too much, or they won't be able to do what they're actually intended to do. The idea is the security model you're using should exactly fit the application. And there's a lot of opportunity here, right? So IAM roles, which I've mentioned quite a lot. Again, it's the kind of profile with which you have access to Amazon, are things that you can change dynamically and things that you can change in response to how they're being used. So at Netflix, we try and deploy every application with its own IAM role. So every application has a unique set of rights to the Amazon environment. And then we monitor that usage using CloudTrail. And then we actually tune it back to be exactly what it should be based upon usage patterns. So a great example would be you write an application, and you frequently update DNS entries. But you also have access to S3 buckets. Because we can log that and monitor your access, we know, for example, that maybe you actually never actually touch DNS. And we can take away that access right and give you exactly what you need and not anything more than that. We're implementing this in a tool called RepoMan for obvious reasons, and we're going to be open sourcing it soon. It's basically taking advantage of a leveraged CloudTrail log and then per application level IAM roles. We feel comfortable giving applications in our staging environment a little more than they need at the beginning, and then taking that away based upon usage, and then we can apply that to production kind of real time as we see those changes. Similarly, with security groups, we have things now called flow logs, and we can actually monitor how security groups are being used and if they're being used correctly. So we can look at how a security group in VPC is receiving traffic. If it's blocking too much, we can actually open that up after investigating it. If it's not actually receiving traffic on ports, we can tune it back and actually restrict it more. So we're working on something for this also. It's a little bit bigger of a problem, I think, just because of the data sets involved. But we'll be looking at releasing a tool for that as well. My own personal hell is S3 policies. I don't know if you guys have dealt with them. The emoji kind of worked there. But S3 is kind of an old technology from Amazon. They do have a very powerful and robust kind of policy system for buckets, but it doesn't really mesh with IAM very well. The kind of collision is very hard to understand. I'd love to see that get improved a little bit, but the goal there would be actually to log S3 usage and do the same kind of tuning there. So again, our pattern is to actually start off with more than developers need during development. We're comfortable with that, and then tune them back based upon real usage patterns. And then to bring that into the production environment dynamically. So at Netflix, we monitor for about 30 days. We looked at how things are being used, and then we adjust the policies, the groups, based upon that usage. And then we bring the developer into that process. So we send them an email that says, hey, we notice you're not using Route 53. We're going to take that away from you in a week. If you really need it, push this button in the email, and we'll opt you out of that. And then we send them another email that says, hey, we just took away your Route 53 rights for your application. If it's broken, hit this undo button, and you can have that back. And then similarly, if there's a production issue going on, we enable developers to kind of break the glass and give more rights to their application. The goal here, though, is to audit that process and to understand when it's occurring and why it's occurring. But to make people feel comfortable, right, they need to have that kind of escape from jail button where they get out of jail free, where they can actually enable themselves to make the changes they need. So we involve them in this process, but the idea is to have those perfectly tuned things by the end of it. And that's what we're calling right sizing, and we're kind of using that in a lot of different areas. So that's kind of dynamically changing security rights based upon usage. So, and I look forward to questions here in a second, just to kind of go over what we've talked about, right? So cloud environments, they're great, they're modern, they're really dynamic, they're programmatically accessible. I really do think they can increase your security if you're implementing them well. The problem is that you need to be able to leverage everything, right? So you need to be able to architect for flexibility and to actually, in your architecture, assume you need to make changes based on security needs. You need to seek to remove those practices which can't be automated, that last silo cup of horrible events that you're not comfortable automating. And then there are other things that can help you along this path, right? ChatOps is probably a great baby step to deal with those things in silo cup number 2. And then right-sizing your environment is kind of that ultimate automation to make you feel comfortable with stuff. So this is definitely kind of a strategy we're implementing at Netflix. We'll be probably talking about this more and releasing a lot of open source tools. Keep an eye out for things that may help you in your environment. And that's it for today. Does anybody have any questions? Yeah.
You mentioned that your developers have root access to the server.
Yep.
Do you also give them access to create their own security groups and instance profiles like that?
Sure. So the question was, I had said that developers have root access to our servers. Do we also give them access to write their own security groups and IAM profiles and that kind of thing, right? So we give them access to make their own security group rules to a limited degree. We ran into some unfortunate situations where developers would, for example, add their home Comcast IP address to a security group, and we weren't very happy about that. So we kind of give them some access. So if they're doing inter-application rules, we allow that pretty freely. But if they're adding IP ranges, we actually restrict that. And if it's something within the environment, that's okay. But if it's external traffic, we actually ask them to come to the security team to implement those changes. For the IAM rules and profiles, we manage that process for them. Yeah. Any other questions? Yeah.
Earlier you mentioned using like elastic load balancing and auto-scaling groups to handle capacity.
Mm-hmm.
Are you guys using much of the serverless architecture with Lambda functions?
Sure. Yeah, I love Lambda. I use it in extremely inappropriate ways right now because I love it so much. I'd say as a company, we're probably moving in that direction more slowly than individuals would probably do it if they didn't have to work with like the legacy of the entire architecture. I think we're kind of strategically writing some new tools in Lambda, but not not shifting our entire workload to it quite yet. But there's certainly great opportunity for automation and scale with Lambda functions. So I personally write almost everything in Lambda now. Other teams, not so much. Yeah?
How often do you audit your security groups?
We audit them constantly. So we have automation around that. We use a tool called Security Monkey, which is open sourced. And basically, we write rules to flag different conditions within security groups to notify us when something changes that probably shouldn't change. So it's a continual process. And then we can pipe those notifications into, for example, our chat channel and be made aware of them as soon as they're notified. Yeah?
How many accounts do you operate, and how much direct access do developers have to the Amazon APIs versus going through some of that good stuff?
So the question was, how many accounts do we operate out of? And then, do developers have direct access to the APIs? How many accounts are there? That's probably how many we have. No. I think we currently have around 50 accounts, and they're there for different reasons. We have probably 2 or 3 really big accounts that have probably 90% of our infrastructure, and then the rest is kind of scattered throughout the rest of them. And in terms of developers having direct access to APIs, so we give them the ability to have access to the same APIs as the application they're developing has. So if their application has a need to reach a certain API, that developer can receive a credential that gives them access to that same profile. Anybody else? Over here.
So you talked a lot about chaos and everyone kind of working together. Is there any automation you can take to enforce things without questioning anyone, without asking anything that they try to lock down?
Yeah. So the question was, is there automation that I guess, things in that third bucket, right, that you automatically respond to and lock down in a fully automated way? We do that for some things. Some of those conditions, for example, having CloudTrail enabled all the time, looking for specific changes to the environment, we would kind of revert those changes automatically based upon some of those templates. So if we see, we have a few security groups that we lock down to the point where we have a template for them. If we notice a change, we actually just revert that without any question, and then expect the process to be to actually update the template. We use actually Git as a collaboration tool for that with a pull request. And then that will get approved or denied, and once it gets accepted, that change will be then actually implemented within the environment. So a lot of these changes are meant to enforce good behavior, good patterns, that kind of thing. And we use kind of templating and the pull request process to make the changes. Like, we still let people make changes via the pull request, but we don't let them do it in an automated fashion. But we enforce that automatically. Does that make sense? Yeah. I think there was another question back here. Yeah.
I have a question. From the auditor standpoint, like if I was a third-party auditor and came in, I know a lot of the auditing methodology is still antiquated when it comes to this type of DevOps mentality. How do you address separation of duties and that nature?
Sure.
Least privilege when you're giving developers all this power to do what they do.
Yeah.
It seems pretty scary to our management to tell them this. And as an ISSO myself, they're pretty scary.
Yeah, absolutely. And so the question was, how do you audit this kind of environment? And then how do you deal with things like separation of privilege for your users when you give them so much power? So we of course, have some compliance regimes we need to actually keep in mind. And our strategy there is to segment those to as small a presence as possible. So like from a PCI perspective, for example, it has its own account that is a very restricted access model. Only certain individuals and teams have access to it. They still need to do like change control, that kind of thing. And we restrict how they actually access instances and that kind of thing as well. But we try and make that as small an environment as possible. And I think the fact that it's kind of a separate system is painful enough for people that they don't want to expand the scope unnecessarily. So a lot of people will, for example, want to have access to something in PCI scope. And as we talk to them about what it means to have that access, and like, your team needs to go through a background check, or you need to use this different pipeline to actually get your applications deployed, they very quickly decide that they'd rather not actually interact with that environment. from an auditing perspective, and I think the challenge isn't not having the right tools, because from an API perspective, I think it's actually easier to audit your own environment. It's working with auditors, especially third-party ones, right, that may not understand the tools you're using and may not understand that you're doing it securely just because they're not familiar with the tool set, right? So it becomes a process of education. And sitting down with them and explaining exactly what's happening, what the flows of network traffic are, and why it's not any worse than a kind of more traditional data center environment. So it's a process of education. Yeah, back in. I'm sorry, what was the last part of it? Yeah. Yeah, so I wasn't lying. Actually, I was lying a little bit. All of our IT is also in the cloud, actually. We very heavily leverage SaaS providers, basically, to do things like email and that kind of thing. So we use Google, for example, and their suite of business services for a lot of things. But truly, like, all the enterprise applications are hosted in the cloud. And let me think. The only thing that we don't host in the cloud is actually the CDN we use to stream traffic, to actually stream the videos, is a custom-built CDN network that's hosted on essentially storage devices within ISPs themselves. So just in terms of the raw bits of video, that's coming from a CDN. That is not part of Amazon, but the logic that feeds it with videos and caches everything, the recommendations, all of the logic and access control is happening within the cloud environment. So how do we segment applications within accounts? We're trying to use a purpose-driven account strategy where we have accounts based on application intent within the ecosystem. So as an example, we have what we call a persistence account, which hosts Cassandra, RDS databases, that kind of thing, because that's where a persistence layer is, and we find it easier to kind of group those together in one environment and manage them on that environmental level and have that segmentation available for different use cases. So really, it's about understanding the purpose of everything and helping people understand which environment they should be deploying into. So kind of purpose-driven stuff, yeah. Over here.
So you mentioned the ability to react quickly to some of these security issues that arise. In the second and third bucket, if things aren't fully automated or are not automated at all, what's the process that you have for triaging security issues?
Mm-hmm.
Who's involved in those decisions?
Sure.
As to how to proceed? I guess, do you guys have like an SLA for turning around security problems?
Sure. So we do have an incident response team that we involve for kind of the big things, and then they would manage kind of an incident response process and then getting the signal to wrap things up. But really, the SLA is the same as any other reliability team at the company. So we're expected to interact and respond to threats as quickly as possible, basically. We have uptime expectations, and security plays into those as well. So we try and get, I think, 3 nines of uptime whenever possible, and whatever turnaround is required to meet that expectation is what we'd have to fit. In terms of SLAs, I think it's all in I think we do like 4, 12, and then 72 based upon severity in terms of how quickly we expect ourselves to react, and then what kind of expectations we set on application owners to resolve issues of different severity levels. So all of that process is managed internally. We use things like Jira and a few other ticketing systems to track it. Yeah. I think that's all the time we have today. We'll be more than happy to chat with people if you have any other questions. Thanks.